In this video, the usage of the new AXISVM result display settings component is introduced. This AXISVM model contains the results of the linear static analysis and a buckling analysis performed on a parametric steel frame structure. The result case list is available on the output of the analysis control component. Now I go to the result display settings component. The AX result case input is currently empty, therefore only the view and model display inputs are considered. To apply the display settings, the start input must be true. Beside the Boolean toggle, I apply a gateEnd component here, and the input A gets its value from the done output of the analysis control component to ensure that these components communicate with AXISVM after each other and not parallel to avoid issues in data transfer. If I set the toggle to true, the selected view and model display type becomes visible in AXISVM. Below these value lists, you can see the result type and result component value lists, which work strictly together. I show this after connecting a buckling result case. Now I open the result type value list. If I change the result type to buckling displacement, the value list of the result component is renamed from line force to buckling displacement, and the value list is filled with the appropriate result components. The selected result component is displayed in AXISVM, and I can change with a Boolean input whether to display deformed shape or not. Let me change the result case to a load combination on the Steel Design tab. I open the result types again. You can see that all result types are included. They are organized similar to the AXISVM logic. I mean, displacements, strains, forces, and stresses follow each other for line elements. The truss, beam, and rib results are not separated. And then for surfaces, other items like support, spring, gap, or link internal forces come afterwards, then buckling, vibration, and design member results. User must take care to select between steel and timber results, and for steel, there's a separate option for the Swiss standard. This example is calculated according to Eurocode standard, therefore I select the other option. I set the result component to MCR and the result display mode to field diagram. Then I change to line shear force to demonstrate the influence of result case configuration. I go to the source of our result case input. Currently, the results are displayed on the Steel Design tab. As you may saw in our other video, this is achieved with the Configure Result Case component that has a linear static result case as main input and a Steel Design member as the bottommost input to tell that we want to work on the Steel Design tab. Disconnecting the design member means that the linear static result case remains as it is, and the results are displayed on the static tab. Reconnecting the design member, we go again to the Steel Design tab. Now I change the input of the result display settings component to a linear static critical combination result case and show you its source. The selected min-max type is displayed in AXISVM. And with a slider, I may choose another result case from the list, for example, an envelope. As a third example, I go back to the buckling result case. I align the settings and show the source of the result case. Here, with a number slider, I change the selected mode shape to any value between 1 and 12 in this example. To show the remaining features of the result display settings component, I go back to the Still Design tab and select the nodal vertical displacements to be displayed. The right values to input of the result display settings component is currently set to false. This means that no labels are displayed in AXISVM. Setting the toggle to true means that the minimum and maximum values are displayed at all available locations, nodes and lines in this case. But instead of simple toggle, I may use a new component to fine-tune these settings. From the results subcategory, I take the right values to component. All its inputs are set to true by default. Let's hide first the nodal results. Then show all values, not only the minimum and maximums. Then go back to minmax, but show results at nodes instead of lines. So simple. I changed to an envelope result case now and open the AXISVM display parameters to show which parameters are driven by the autoscale and displayed envelope inputs of the result display settings component. I would like to introduce the usage of the X color legend input as well. If no input is connected, the automatic settings are applied in AXISVM. As input, a new item of the add-on, the color legend settings component, can be used. I'd like to change now the level count of the color legend to 10 using the first input parameter. Then I show how to influence the gradient of colors, switch between reverse and normal gradient with a Boolean input. And there is an option to separate the positive and negative values with a 3-level legend. If this option is true, the custom level count is irrelevant and not considered. Okay, now going back to the legend with 10 levels and creating the legend type value list from the pop-up menu. We can choose from the legend types similar to the Values tab of the AXISVM color legend setup. I may define custom levels, feeding the component with a list of ascending numerical values. I take care to define the values in meters and disconnect the unnecessary level count input. It is important that the values must be in ascending order, but they are not required to be equidistant. The level intervals may vary. There is still one input parameter to be mentioned, the duration, which is practically a delay in seconds. This means that the done output of this component is changed to true with the given delay after the display settings have been applied. Thus, user may keep the results on the screen, for example, between two finite element analysis. As a closure, I'd like to mention that if the user selects an invalid or not available display setting combination, error message is quite rarely returned on the output of this component. AXISVM uses rather its available automatic or default display settings in such cases.